Chemistry 1, Chapter 2, Measurements and Calculations. This first video is going to go through density calculation examples. So, units of measurement. There are many different units of measurement in science because there are many different things that can be measured. So, scientists worldwide agreed on a single system to have uniform measurements throughout all of our countries. So it's called the SI system. The SI system has 7 base units, and you can see them in the color wheel to the right. All of the other units we use for measurements are derived from these 7 base units. So in your notes, make a little chart and copy this down. So length, our SI base unit is meter, abbreviated lowercase m. You can also have kilometers or kilometers, centimeters, and millimeters. Their abbreviations are seen there, all lowercase. Mass, the base unit is kilogram. kg, once again, lowercase. The other most common unit is grams, lowercase g. Time, we measure in seconds. The abbreviation is SEC. You can also have minutes. Temperature, the base unit is Kelvin temperature. We also have Celsius and Fahrenheit units for temperature. Amount of substance is measured in moles. The abbreviation is MOL. There are no other units derived from the base unit mole. And lastly, volume, its base unit is liter. Could be a capital L or a cursive lowercase l. And the most common other unit derived from it is milliliter, which is a lowercase m and a capital L, or a lowercase and cursive m and l. So using scientific measurements, the first measurement we're going to talk about is density. So density is defined as a measurement of how tightly packed together molecules are. A lot of times people associate density with weight. Weight and specifically mass do have something to do with density, but density is just how tightly packed together are those molecules. So for example, the first picture represents low density. The molecules are very spread apart. And then you increase to high density, the closer together the molecules get. So calculating density. The equation is mass divided by volume. So as I said, mass does have a factor in density. Remember, mass is how much matter something has. So the abbreviation is D for density equals M for mass over V for volume. I like to tell students to think of a heart, because when you draw a heart, you have an M on top and a V on the bottom. So mass over volume. There are 2 different common units for density. The first is grams over milliliters, which is abbreviated G over ml. Or you could also have grams over cubic centimeters, G over cm cubed, or to the 3rd power. So it just depends on, the mass is always going to be in grams. It just depends on the volume measurements units as to which one of these you use. So first example, try this out in your notes. Actually try it so you know what you're doing. Calculate the density of aluminum that has a mass of 4.8 grams and a volume of 5.1 milliliters. So first important parts, we have our mass here, our volume here, and it says to calculate the density. So all we have to do is use our density equation and plug in the numbers. So once again, density is mass over volume. So my mass is 4.8. G for grams, you need a unit. And my volume was 5.1 milliliters. Those 2 units are not the same, so they do not cancel out. So do your math, plug it into the calculator. 4.8 divided by 5.1, and I get about 0.94, and my unit is grams over milliliters because I didn't cancel them. I would like you to round 2 decimals if possible. I don't need the rest of the decimals, but I also don't want you to over round. So don't just say 0.9. So that's the most basic example. Mass and volume given to you, plug them in, chug out your answer. All right, example 2. Try it out on your own. Calculate the density of a block of marble that occupies 130 milliliters and has a mass of 735 grams. So once again, where are the important parts? I have this number with a unit, I have this number with a unit, and I'm calculating density. Okay, so once again, I need to use the general, let me get my pen here, the general density equation. Density equals mass divided by volume. But the tricky part is this number comes first. You have to look at the unit, which is milliliter. That means that's volume. That number is going to go on the bottom. This number has a G, grams for mass, so that number is actually going to go on top. So make sure that you're actually reading the numbers with their units. Don't just plug them in because of the order. It can be in any order. So 735 divided by 130, and I get about 5.65. And my unit again is grams over milliliters. All right, next up. Diamond has a density of 3.26 grams per milliliter. What is the mass of a diamond that has a volume of 6.5 milliliters? So pick out the important parts. Density given there, volume given there. What is the mass? Now I'm not solving for density. So density equals mass over volume. Now I have to solve for mass, m. So I'm going to put a box around it. This is what I'm solving for. I have to get m by itself. How do I get m by itself algebraically? Well, I have to take it, and if I'm normally dividing by volume, I have to multiply both sides by volume, which will cancel out volume on the right, and I'm left with volume times density, or density times volume, equals mass. So now this is the equation I have to use. So find the mass, m, given a volume and a density, or density and a volume. It doesn't really matter the order since we're multiplying. So mass is going to equal my volume, which is in milliliters, 6.5, times my density with the units gram per milliliter. Now I have milliliter technically over 1. It's on the top. This milliliter is on the bottom. So they're going to cancel each other out, and I'm only left with grams. So 6.5 times 3.26, and I got about 21.19 grams, because mass is what I'm finding, and it is in grams. So that's just when you have to rearrange the equation. Okay, last example. What is the volume of a sample of liquid mercury that has a mass of 76.2 grams, given the density is 13.6 grams per milliliter? So once again, pick out the important parts. So density is given here, mass is given there. What is the volume? So once again, I'm not solving for density, so I cannot use the density equation without rearranging. Okay, so let's just plug in the numbers. So this is going to be density is D, 13.6 grams per milliliter, equals a mass of 76.2 grams, and I'm finding volume. Okay, so this is what it looks like right now. So what you have to do is you have to flip-flop these. Okay, algebraically, you would take both sides by V. Okay, that would cancel this out. and you would have volume times density equals mass. But you want to find volume. So then to get rid of the 13.6 density, you would have to divide both sides by it. So then you're left with volume equals mass over density. Okay. So we're finding volume, which is going to be in milliliters. So these are going to cancel. So 76.2 divided by 13.6 equals 5.6 milliliters because I'm in volume. Okay, so just to reiterate, let me real quick, just want to show you. So the equation for finding density is just D equals M over V. Mass in grams, volume in either milliliters, which is all we've done so far, or the next video, cubic centimeters. If you want to find mass, you have to take the original equation and get M by itself. So you take both sides by volume. Those cancel. So you're left with mass equals volume times density, or density times volume. The last equation, solving for volume, once again, you start out with the original equation. I want to get V by itself. So the quick trick is just to flip-flop V and D. V equals M mass over D density. So those are the three equations you have to know for the calculations. So you should now be able to go and complete the density worksheet, which is the next assignment for today.